In this episode, we replace the wet and rotting plywood core of the fuel tank cover hatch on our Grady White restoration project boat. Please stick around if you'd like to see how it goes. G'day, I'm John, currently living in Bermuda and attempting to restore a 1996 Grady White Adventure 208. When we purchased the Grady, the fuel tank cover was very soft or spongy underfoot, and a reading of the moisture meter showed that the core material was very wet. The hatch probably hadn't been lifted since the boat was made, but a few screws and cutting through the silicone sealant allowed us to lift the hatch pretty easily. Once lifted, the bottom of the hatch was very wet and covered in a black slimy material. We cleaned this up with some degreaser and then had to remove the old fiberglass skin to get at the core material. In previous boat restoration projects, I'd found that a multi-tool with a titanium or carbide tip blade was really good for cutting through fiberglass. Unfortunately, my new Ryobi multi-tool died after just 14 minutes cutting. As far as I can tell, the problem is that while the motor runs, some internal gearing is broken and the blade won't oscillate anymore. At the time of publishing, Ryobi were pretty good about providing a replacement. Unfortunately, they'll only send it to a US address and won't provide any paperwork for export to Bermuda. I wonder if I'll ever see it. Just one of the many joys of working in Bermuda. Fortunately, I'd nearly finished cutting by the time the tool died. So I tried prying the old fiberglass skin off the wet wood. Generally it came off easily enough, but did stick around the cross beams or ribs, not sure what you call them, and that meant a trip to the hardware store to find the cheapest multi-tool available on Bermuda, which still wasn't cheap. The new multi-tool made short work of cutting out the cross beams and removing the remaining fiberglass skin, which I think was probably just a single layer of chop strand matting. You can see here just how poorly the wood is attached and how wet it is. With a pry bar, most of the wood came off pretty easily. With the wood removed, it just left the thin outer skin of fiberglass. It looks like the manufacturer used some gel coat with chop strand matting on top of it to glue the wood down. I used an angle grinder with a 40 grip flap disc to cut through the remaining bits of wood on the chop strand matting, but you do need a gentle touch as it would be pretty easy to grind through the very thin outer skin. Once that was done, the last step was to remove the inspection hatch and clean up. But why was the core material so wet? While the hatch was screwed down and sealed with silicone, the fuel tank compartment was open to the bilge and Bermuda's hot weather made that a pretty steamy environment. The single layer of chop strand matting wasn't sealed well either, with quite a few holes and cracks to let the water in. However, the bigger problem seems to me to be the screw holes, which weren't caulked or sealed in any way that I could see. This allowed water into the end grain, which, over the past 30 odd years, permeated throughout the plywood. Anyway, with all the old material removed, it was time for the new core. The original plywood was 12.7 mils thick, or half an inch in freedom units.
Distance will be measured in inches, feet, yard, and mile. So 12 inches to a foot?
12 feet to a yard.
If it were only so simple.
I used Divinycell foam for the core material, but the only importer on Bermuda had a limited amount of stock and wasn't bringing any more in. However, I was able to get a sheet of 3/8 of an inch or 9.5mm foam, and then I could double it up to be 3/4 of an inch or 19mm thick. Divinycell seems great stuff. It's very easy to work with and shape, is light, has good compression strength, and is water resistant. As the foam didn't fit the hatch shape exactly, we cut smaller pieces for the 2 layers and made sure that the joins or butts on one layer were over solid material on the next layer. The foam core was sandwiched between layers of 1708 fiberglass. I used epoxy resin on the glass, and during the Christmas-New Year holiday period there was only one supplier open on Bermuda, and they charged the very reasonable price of $158 US for 1 quart, that's a bit under a litre, of West Systems epoxy and fast hardener. Have I mentioned that Bermuda's an expensive place to live? Certainly suboptimal for a boat project. Anyway, with a somewhat uncertain weather outlook, though it was relatively warm at about 18 degrees Celsius, don't ask me what that is in freedom units, we mixed up some thickened epoxy to help fill any voids between the outer skin and the first layer of 1708, and then some more to glue down the 2 layers of foam. Unfortunately, 2 quarts of epoxy wasn't quite enough, but we did manage to finish the job just before a light rain set in. But some plastic sheeting protected the job pretty well. I was pretty happy with the outcome, but there were 2 spots where there wasn't quite enough glue, and we'll have to stick them down again later. I wanted to fill the outer edges with thickened epoxy to limit future water damage, and in hindsight should have made the foam panels a little smaller, but it was easy to trim them back. I also needed to sand the edges down a little bit so the hatch would sit flush with the deck. To ensure the next layer of glass stuck, I cleaned off any amine blush with warm water and a little detergent. Then roughed up the first layer with sandpaper for a better mechanical grip with the next layer. After vacuuming and cleaning with acetone, it was ready for the next layer. With the stores open after New Year, I was able to get a gallon, or about 4 litres of Hawk epoxy, for almost the same price as a quart of the West Systems. I thickened the epoxy with F2 and F3 adhesive filler to fill the voids around the edge, make some fillets near the inspection hatch, and glue down the last bits of foam. Unfortunately, it was about here my GoPro battery ran out, so I missed applying the next layer of 1708. While I have a bit of experience with polyester resin, see my centre console conversion project here, this was the first time I'd used epoxy and I had 2 problems. Firstly, it kicked off much faster than expected, and secondly, I was limited in my tools. I didn't have a fin roller, for example, so ended up with a few air pockets. I'd grind these out later, but firstly it was trim the edges and wash the next layer of amine blush off. To further strengthen the hatch, I made some cross beams or ribs out of 2 layers of foam for an extra 19mm. I made 3 and spaced them about 40 centimetres apart, either side of the inspection hatch. You can see here all the air pockets I ground out. I put fillets of thickened epoxy around the ribs and then covered them and the holes with another layer of 1708. Then it was washing more amine blush off and then sanding the sharp bits of the fiberglass. Possibly not the prettiest job, but I think it's better than the previous one. Certainly more water resistant. It was a learning experience for me, and I just hope that we won't need to lift the hatch for another 30 odd years now. I put the inspection hatch back and it was time for a test fit. However, I did need to drill new screw holes, and I also picked up some new stainless steel number 10 2-inch screws. There I am talking freedom units again. Bermuda has an odd mixture of weights, measures, driving and navigation rules. Building supplies are mostly in freedom units. Road distances and speeds are metric, and they drive on the left as in the UK. But the navigation buoyage system is the same as the US, IALAB, where the colours and shapes are reversed from just about everywhere else in the world outside the Americas. Anyway, the new screw holes didn't quite line up with the old ones, so I filled the old ones with thickened epoxy and re-drilled them. Finally, the hatch was ready to go back in. I think that's a success. It handles my 95 odd kilograms pretty well. Now it's time to try and fit the new fuel tank.
5,